welcome to another video. It's just math, y'all. We are going to be looking at rational inequalities. Last time we did polynomial inequalities. Today we're going to look at rational inequalities. We're going to learn how to solve a rational inequality. Here we go. Here's our first example. Remember, a rational function or a rational inequality has a situation with the denominator. Okay, so the first thing we're going to do, it says set the numerator equal to 0 and solve. So you notice I've done that. I did x minus 4 equals 0, x equals 4. And then step 2 says set the denominator not equal to 0 and solve. And this is just a reminder that the denominator technically can never equal the answer there. So in this problem, it can never equal 1. So then I'm going to create my intervals, put my number line out there, and put my numbers in there, and I've got my intervals. But notice the 1 has a hole on it and the 4 is colored in. That is because we are looking at a closed interval for the numerator, an equals, and then a never ever equal the 1. Okay, so this is what we're going to do. So we've created our intervals, and now we're going to plug in our test numbers just like we did before when we did the other ones. So I'm going to test a number here. I'm going to test the number, what's less than 1? Well, there's all kinds of stuff next to less than 1. Let's see what I can put. I can put a 0 here. So let's test 0. Test a number. Let's test 0. So I'll plug in 0 and see what I get. I don't like that. That's too thick. Here we go. So I'm going to have 0 minus 4 and 0 minus 1. And that's going to give me negative 4 over negative 1, which is a positive 4. This is a positive answer. Okay. It doesn't matter what the number actually is. That one was so easy, I just did it. It doesn't matter what the actual number is. I just need to know if it's positive or not. Right? Next section, I got to pick a number between 1 and 4. So I'm going to choose, let's choose 2. So I'm going to test 2. It doesn't matter, so I'm going to plug in 2. 2 minus 4 and 2 minus 1. The top is negative. The bottom is positive. So my answer is negative. Now I could continue figuring out what the actual number is. If I wanted to, I could do that math. I don't have to. Might as well do it. It's negative 2, but I don't have to. The only question is it positive or negative? Next up, we have 4. We're going to check a number over here. So over here we have numbers 5, 6, and 7. So I'm going to test one of those. Doesn't matter which one I'm going to do. I'm going to test 7. And so I have 7 minus 4 over 7 minus 1. Both of these subtractions are going to produce a positive number. And a positive divided by a positive is, of course, a positive. Doesn't matter what I've chosen. Okay, so I've done step 1. I set the numerator equal to 0 and solve. Step 2, set the denominator not equal to 0 and solve. Step 3, I created my intervals and plugged in test numbers for step 4. So now technically the last answer is to come up with my answer. Well, what's the question? The question is, what are the x's that are going to produce greater than or equal to 0? Well, the ones that produce equal to 0 were the 4. That was the one that produced equal to 0. That's from the numerator. Okay, and then the ones that are greater than 0 is positive. So let's find the sections where we have positive. This section produced positives, and this section produced positives. This interval produced positives, this interval produced positives. So my answer is negative infinity to 1. It's closed. Open. It's open, parentheses there. And then 4 to infinity at the u. This one's closed. This one's considered open. So there's that one. Let's try another one, a little bit more complicated. This one, we have another rational inequality, and we're going to do the steps like we did before. We are going to set the numerator equal to 0 and solve, and then we're going to set the denominator not equal to 0 and solve. So here we go. So the numerator set equal to 0 to solve, just for the sake of saving some space. X plus 5 equals 0. That gives me x equal negative 5. X minus 7 equals 0. Add 7 to both sides, and I get x equal to 7. Okay. Now the denominator. Set the denominator not equal to 0 to solve. So x plus 3 cannot equal to 0. Subtract 3 on both sides. X cannot be negative 3. Okay. Again, we have an equals on this guy right here. So these are going to be solid circles or brackets. Right, I'm going to draw my number line. I have negative infinity here, positive infinity here, and I have negative 3, negative 5, and positive 7. So I'll put those on here. Negative 5 comes first. Then I have negative 3, and then I have positive 7. Again, I'm not doing this to scale. X can never be negative 3, so I'm going to have an open there, not equal to negative 3. But we've already said that x equal to negative 5 and 7. So what are my intervals here? So this one is negative infinity to negative 5. This one is negative 5 to negative 3, negative 3 to 7, and 7 to positive infinity. So I have 4 sections. I'm going to test 4 sections, 4 points I'm going to have to test. And again, all I'm testing is positive and negative. I don't need all the numbers that's going to happen here. I just need positive and negative. Okay, so we're going to pick a number. So what do we have here? We have, let's see, we have negative 6, negative 7. Which one do you want to test? All right, let's test negative 7. I'm going to plug in negative 7, so negative 7 plus 5, negative 7 minus 7, over negative 7 plus 3. Again, I don't need to know what the answer is, I just need to know if it's positive or negative. So that first one's going to give me a negative, the second one gives me a negative, and the bottom one gives me a negative. So I have a negative times a negative, which is a positive. This is going to give me a negative answer. This section gives me a negative answer. All right, let's go to the next one. What can I plug in between negative 5 and negative 3? I think that's going to have to be negative 4. So let's test negative 4. So negative 4 plus 5, negative 4 minus 7, and negative 4 plus 3. Let's do the positives and negatives here. First one's positive, second one's negative, third one's negative. So that's going to give me a negative divided by a negative. That's going to be a positive. All right, I got to test another number. We got 2 more to go, 2 down, 2 to go. So now what am I going to plug in? So let's see, what do we have between negative 3 and 7? That's 7, that's 6, 5, 4, 3, 2, 1, 0. I could plug in 0. Would you like to plug in 0? Sure, let's plug in 0. So let's plug in 0. So that's 0 plus 5, 0 minus 7, and 0 plus 3. I could do the numbers if I wanted to. This is going to give me a positive 5, but it's positive, and negative 7, positive 3. So I have a negative divided by a positive, which is going to be a negative. One more. 7, what comes after 7? How about 8? 9? What do you want to test? You want to test 8? Let's test 8. You like 9 better? Go for it. It won't matter. So let's test 8. So 8 plus 5, that's positive. 8 minus 7, that's positive. And 8 plus 3, well, that's a positive number as well. So all of these are positive. Okay, I've done my 4 steps. Now I need to know what my answer is. What in the world's my answer? Again, what was my question? All right, we want to know all the x's that produce less than 0 or equal to 0. Less than 0 or equal to 0. That's what that says. Less than 0 is negative. So I go down here. These numbers produce negative. That's part of my answer. These numbers produce negatives. That's part of my answers. Okay. And equal to 0, well, the negative 5 equals the 0, and the positive 7 equals 0. So my official answer are these two sections. I have negative infinity to negative 5. There should not be a bracket on that infinity. Don't know where that came from. And then the negative 3 to 7 with the bracket, and we put the u. And there's the answer there. Again, it matches your number line. Pay attention to your number line. Let's see what you do. All right. Let's see if you can do these on your own. I don't give you very many of them. But these are rational inequalities. Have a great day. It's just math.